So now that we have understood how to integrate basic functions using the understanding of integration as the inverse process of differentiation, now we'll go into methods of integration. It is what are the different advanced methods that we have to integrate complicated functions. So the first and most important method to say is the method of substitution. Method of substitution. So using this method, we try to convert complicated integrals into simple integrals. For example, the most often used form in this method of substitution is if you have a composite function, that is f of phi of x. So instead of a very simple function, you have some function which is made up of some other sort of functions, that is f of phi of x. And if this is also followed by the differentiation of this phi of x dx, that is, if the integrand, this is called the integrand, the expression inside integral is called the integrand. So if the integrand is of this form, that is f of phi of x times phi dash of x, that is, whatever the first function is made up of, you have the differentiation of that as a multiple, as a term which is getting multiplied. Now what you can do is, you can substitute let phi of x is equal to t. So if you substitute phi of x is equal to t, phi dash of x dx, if you differentiate this on both sides, you get phi dash of x dx is equal to dt. Phi dash of x dx is equal to dt. So this phi dash of x dx goes into dt. So this integration becomes integration of f of t dt. So this substitution phi of x is equal to t usually simplifies the integrand, and after the integrand is simplified, this can be easily integrated. This can be easily integrated. So this is the most often used form of substitution. So in substitution, what you need to see is, whatever the first function is made up of, if you have the differentiation of the term followed by this function, the substitution process is very easy. And you have some special case of these substitutions. That is, if you have f of x power n. So if you have a function which is made up of x power something, and if it is followed by x power n minus 1, it is followed by x power n minus 1 dx. So what we can do is, we can substitute x power n is equal to t. This implies that dt is equal to n times x power n minus 1. So x power n minus 1 into dx. So x power n minus 1 dx can be written as a dt by n. So this becomes integration of f of t dt into 1 by n. So this integrand becomes quite simplified when compared to this integral. And if you have integration of something like f of x, a simple function, followed by its differentiation dx. So if you have a function multiplied by its differentiation. Now what you can do is, you can assume f of x is equal to t. So f dash of x dx becomes dt. So this becomes integration of t dt, which is t square by 2, which is equal to f of x whole square by 2 plus c. So if you have a function followed by its differentiation, the direct integration for this integrand is f of x whole square by 2. So it is a very simplified formula which can be used many times. And next, if the integrand is of the form integration of f of x power n times f dash of x dx, f of x power n times f dash of x dx. So in this case, again you can assume f of x as t, f dash of x dx becomes dt. So this becomes integration of t power n dt. So this integration becomes t power n plus 1 by n plus 1 plus c. And finally, if you do the back substitution, the formula for this is f of x whole power n plus 1 by n plus 1. So if you have fx power n times f dash of x dx, the answer is fx power n plus 1 by n plus 1 plus c. For example, if you have integration of sine power 6x times cos x dx. So sin x differentiation is cos x. So if you assume sin x as t, cos x dx becomes dt. So this becomes integration of t power 6 dt. So the answer is sin x power 7 by 7 plus c simply. So integration of fx power n times f dash of x dx is equal to fx power n plus 1 by n plus 1 plus c. And you have integration of f dash of x by f of x dx. This type of integration is also very simple, because if you assume f of x as t, the numerator becomes a dt. So this becomes dt by t, which is equal to log mod t plus c. So integration of f dash of x by f of x becomes log of mod of f of x plus c. So these are very standard formulas which you can directly use to your advantage. So let us take some examples and see how to use these formulas that we have. For example, so if you have to integrate 1 plus tan cube x followed by secant square x dx. So normally if you have to do this integration by the previous methods, it is very difficult. Now using the substitution method, so what we first do is we'll try to simplify this integral. So here you observe that the first function is made up of tan x in something, and tan x's differentiation is secant square x is followed. So what we can do is, in such type of questions, let tan x is equal to t. So once you assume the substitution, the next step will be the differentiation of this substitution. So tan x implies secant square x dx is equal to dt. So if you substitute the difference, if you differentiate the substitution, secant square x dx is equal to dt. So if you put everything in the integrand, this integrand becomes integration of 1 plus tan x is assumed as t, so this becomes t cube, and secant square x dx is equal to dt. So 1 plus t cube dt. So you have t plus t power 4 by 4 plus c as the answer. So 1's integration is t cube's integration is t power 4 by 4. So once you complete this integration, you can put back the function. So t is nothing but tan x. So the answer is tan x plus tan power 4x by 4 plus c. So this is the integration of 1 plus tan cube x into secant square x. Next, for example, if you want to integrate log x by x dx, log x by x dx. So how do we do this? So if you carefully observe, log x is a function and it is followed by 1 by x dx. Log x's differentiation is 1 by x. Log x's differentiation is 1 by x. So you need to look for this. So whenever you assume something as t, so you have to have some sort of differentiation of it somewhere following the function. So then substitution becomes useful. So in this question, let t is equal to log x. This implies dt is equal to 1 by x dx. So what does this integration becomes? Integration of log x is t and 1 by x dx is simply dt. So the answer is t square by 2 plus c. That is log x whole square by 2 plus c. So I hope this is clear. So everywhere in the process of substitution, you have to look for differentials. So it takes something as t, you have to have some sort of differentiation of it following the function. So if you take integration of 1 by x log x dx. So again, here also let us put log x is equal to t. So let t is equal to log x. So dt is equal to 1 by x dx. So 1 by x dx becomes dt. So this integration becomes integration of dt by t. dt by t. So what is the integration of 1 by t? Integration of 1 by t is log t. So ln t plus c, ln mod t plus c. So t is log x. So the final answer is log of mod of log x plus c. So integration of 1 by x log x is log of mod log x plus c. So I hope you're understanding the basic principles of substitution. So let us do extensive practice of this afterwards. So let us take a small concept and then we'll move on to questions. So the concept that we're going to discuss is this. If integration of a function f of x dx is some g of x plus c, that is, if you know the integration of f of x as g of x, then integration of f of ax plus b, that is, in the place of x if you put ax plus b, then the integration becomes the same function g of ax plus b divided by a plus c. So this is the formula that we are going to discuss. So if integration of fx dx is gx, then integration of f of ax plus b dx is equal to g of ax plus b by a. So let us see how this happens. So if I want to integrate f of ax plus b dx, so what I do is let ax plus b is equal to t. This implies if you differentiate both sides, a dx is equal to dt. So this integral becomes integration of f of t into dx becomes a dt by a. dt by a, that is equal to 1 by a goes outside, and integration of f of t dt. So integration of f of x dx is g of x plus c, and integration of f of t dt is g of t plus c. And if you do the back substitution, t is nothing but ax plus b. So this becomes g of ax plus b by a plus c by a. Both are constants. So this gives rise to another arbitrary constant. So integration of f of ax plus b is g of ax plus b by a plus c. So let us see how to use this. This is a very important formula that you need to keep in mind. For example, so we know that integration of cos x dx is equal to sin x plus c. We know this. Now, if you are asked to integrate cos of 2x dx, integration of cos of 2x dx. So as you can see in this formula, so you just have 2x in the place of x. So x is replaced by something like ax. So the answer to this will be sin of 2x, cos 2x, sin 2x, but it will have to be divided by 2. So because this is of the form ax, so you have g of ax by a plus c. So in differentiation, we usually do the multiplication of these two. So differentiation of cos 2x is minus sin 2x into 2. This is the opposite of that process. So in integration, the multiples come into the denominator. For example, integration of tan of 2x plus 3 dx. Sorry, integration of tan square of 2x plus 3 dx. So this can be written as integration of 1 minus tan square of x is secant square x minus 1. It is secant square of 2x plus 3 minus 1 dx. Now this is equal to integration of secant square 2x plus 3 dx minus x plus 3. So what is the integration of secant square 2x plus 3? The integration of secant square x is tan x. What is the integration of secant square 2x plus 3? It becomes tan of 2x plus 3, but it have to be divided by 2 because x is being multiplied by 2, so you have to divide the function by 2 minus x plus c. So if x is replaced by ax plus b, the answer will be the function g of ax plus b divided by a plus c. And this formula stops here. If in the place of x, if you have x square or some other function of x, the chain rule does not work. Integration of cos of x square dx. This cannot be written as sine of x square plus c. This cannot be done. So the formula is only if x is replaced by ax plus b. A linear x is replaced by a linear ax plus b. So if you have any other substitution, the formula doesn't work. So if for this particular substitution x by ax plus b, in the answer also you substitute x by ax plus b, but you need to divide by a. That's the extra thing that you need to do. Now we'll look into some standard questions on this topic of substitution.